integrate the function I is equal to e to the power of 2x into sine of x dx. So both these quantities are one which keeps on repeating. Whenever we get repeating scenario, right, you have to do it 2 cycle. Okay, let me explain that. So differentiating this will give us back this itself, not maybe exactly that, but similar to that. Differentiating sine of x 2 times will give us back sine of x. So when we have repeating functions or cyclic function in some sense, so we have to do the following. So from this, the underlying principle is that we need to go 2 cycles. Okay, let me show you what does that mean. So I'll call u here as, say, sine of x, and or maybe e of x, e of 2x, and v as sine of x. So the derivative of this would be 2 into e to the power of 2x, and v being integrated would be minus cos of x. And now let's list the formula. So integration of uv is equal to u integration of v dx minus integration of u prime v dx dx. So we have I is equal to u is e to the power of 2x into this would be minus cos of x. This would be minus of minus plus, and here is 2 e to the power of 2x, and this is cos of x. Remember, minus I have already taken it out, so that presence of mind will always help, dx. So we can see that nothing has changed over here, right? Yeah, 2 has been added to this. Other than that, nothing has changed. That's why I meant repeating functions. Okay, so if I take, sorry, e to the power of 2x cos of x plus I2. If I take this as I2, 2 times of I2, let me do that. So I2 itself is a similar question to whatever we just started off with, right? So here too, if I take u as e to the power of 2x, can you see that? Is deja vu. Sine of x, in place of sine of x, we have cos of x. So here u prime will be equal to 2 into e to the power of 2x, and integration of v dx is sine of x. But here there is no negative, right? And so we have I2. Since we have already written the formula, we just have to express this, then minus of integration 2 e to the power of 2x, and this is sine of x dx. But what is this? It's the question itself. So end of it, let me do this. So this is e to the power of 2x sine of x minus 2 times of I. This is from 1, and 1 being this. Okay, so if I substitute it back to, say, a, sub in a, sub I2 in a, or I can just directly write I is equal to, so I is equal to minus e to the power of 2x cos x. Okay, so you have to be careful when we are copying. Plus 2 times of I2, plus 2 times of I2, which is e to the power of 2x sin x minus 2I. I told you, right? 2 cycles. So we have a bit of math over here, minus e to the power of 2x cos of x plus 2 e to the power of 2x sine of x minus 4i. If I transpose minus 4i, we have 5i is equal to, if I take e to the power of 2x common, then we have 2 sine of x minus cos of x, and finally I have I is equal to e to the power of 2x by 5 2 sine of x minus cos of x plus a constant. Right, this is what I meant by cycle. So whenever we get any kind of trigonometric expressions like sine and cos, and basically anything to do with sine and cos and e to the power of x and all of that, so any such pattern, it would be of cyclic manner, and you will end up with such a scenario wherein you will get I again and transpose it and you will get the answer. Okay, so don't panic if things are repeating. It's good, because if we go back to the initial point, we can substitute I back and we have the answer. Okay guys, so you can pause and have a look. I just want to change this as repeating function on differentiation. So e to the power of x is not exactly cyclic, right? So repeating functions on differentiation. Okay guys, so whenever you get such a scenario, so by default the answer will look something like this. We have to go 2 cycles and we'll get back I, and that's how it is. Okay, so just keep this in mind, it will help you guys.